chat එකේ දාන්න පුළුවන්. ෆෝන් එකක් ප්‍රශ්නයක් ආවොත් WhatsApp එකේ හරි call එකක් දීලා හරි කෝක mic එක on කරලා හරි අහන්න හරි. Then we need to know about the frame of reference. Frame of reference, right? This frame of reference means this is the frame which the observer sits and making the observations. If some observer is there, let's say, with respect to some other frames, so observing this frame and is taking the observations. So this frame is called the frame of reference, right? Generally, in a 3D space, we consider that the XYZ axis to take the observations, right? We already know that to three mutually perpendicular axes we use as a Cartesian coordinates to explain about the motion of a body. So this Cartesian coordinate system is called the frame of reference, right? These three mutually perpendicular axes are intersect at the point. We call it the origin of this frame. Generally, we get the measurements with respect to these three axes. One-dimensional motion, we consider only one axis. In two-dimensional motion, we consider the two axes. And three-dimensional, we consider the all. Other than this, there is a polar coordinate system and also cylindrical coordinate system. Also there, right? And there are two different types of frame of references. So one is the inertial frame of reference. This inertial frame of reference. And the second is the non-inertial frame of reference. Non-inertial frame of reference. The inertial frame of reference means they are the frames which are not accelerating, right? That means the frames not accelerating with respect to the another inertial frame, right? So these are the frames which are moving with constant velocity or be at rest. Yeah, that means not non-accelerating, right? So these are the frames which are moving with constant velocity or at rest with respect to the another, right? So these are inertial frames. The Newton laws of motion only valid for the observation taken from this inertial frame of reference. Later I will discuss about how that's affected to the system. Then after we discussing the Newton laws, I will show you that how it's valid only for this inertial frame of reference, right? The examples, when you consider that, normally we consider our Earth is an inertial frame of reference, but actual case, the Earth is not the inertial frame of reference, right? Because we know that when the Earth orbiting around the Sun, it has an acceleration towards the center of the Sun. We call it a acceleration, centripetal acceleration. Clear? So then we can't actually consider this frame as a inertial frame, the Earth as an inertial frame, but for the calculations and other cases in your study about this lesson, you can assume that that's a inertial frame of reference. And also any body which is moving with constant velocity, any space shuttle moving with the constant velocity relative to the relative to the Earth, let's say, and rocket moving with constant velocity, also we consider as the inertial frame of references. The non-inertial frame of reference means that's the frame which are accelerating, right? It's accelerating, and also its acceleration can be changed time to time. So the Newton laws of motion are not valid for the observation taken from this non-inertial frame of reference, right? Any body, any vehicle which is moving with some acceleration, we can consider as non-inertial frame of reference. It is also important to get this definition of these two, and also you need to know that hello. කවුද මේ කතා කරන්නේ? කවිතා ප්‍රශ්නයක් තියනවද? නේ. කවුද? 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 මොනවද තියෙනවද අහන්න හදන්න. වැඩි ඉන්න සමහරවිට එන්නේ නිකන්. මොනවද තිබ්බත් අහන්න මොකක් හරි අහන්න. මට නැත්තම් මෙසේජ් දාන්න මම කොයි විදිහට chat එක පැත්ත බලනවා. Here, that's not initial frame of reference. And also you need to keep in mind in MCQ questions also they can ask that this different frame of references and you need to know uh, which system, which frame you can apply this Newton laws of motion. Right? And I'm considering something about this inertia and these frames. I will give a small description like this. Let's consider the train is moving, right? There's a train, let's see. So initially you consider it is at rest. So there is a suspended pendulum. Yeah. An observer inside this. I'll explain this later after we discuss about the Newton laws also. මම මේකට එන Newton laws වලින් ප්‍රශ්න. හරි. ඒක පොඩක් වැඩි understanding එක ගන්න පුළුවන්. Okay. Is there any things to clarify on up to this point? Then we will move to the momentum part. We're going to the linear momentum. Linear momentum of a body means it's the moving body actually. The moving body, the linear momentum is how much the amount of the motions possessed by the body, right? In mathematically, we can write this linear momentum equals to the product of mass and the velocity. Mass into velocity. Symbolically, we can write this V equals mv. These are vectors. The momentum is a vector and also the velocity is a vector. The direction of the linear momentum is same as the direction of its velocity. Yeah. So the momentum is a vector quantity. You need to know about it. Vector quantity. And it's a SI unit. SI units, that's a kilogram meter per second. Or we can say it as Newton second. Newton second. I want to inform you that at some point that මේ මම මේක අර Zoom එක ලයිසන් කරලා තිබෙනේ online class කරපු නැති හින්දා. ඒක 10 minutes වලින් සමහර විට end වෙයි. ඊට පස්සේ ඔයගොල්ලෝ මම ආයෙ link එක දාන්නම්. ඒකෙන් join වෙන්න ආයෙ හරි group එකට. මම link එක දාන්නම් අලුත් link එක මොකද වෙන්නේ. ඒක ඉවර වෙයි සමහර 10 minutes වලින්. හරි. ඔයගොල්ලෝ මම මේක අප්ඩේට් කරලා තිබෙනේ මට ඒක අමතක වුණා. online class කරන්නේ දැන් ඉතින්. හරි. Okay. The SI unit is kilogram meters per second or Newton second, we can say. It's Newton second in SI base units. SI in SI, other SI units, you can say Newton second, right? Okay, when you consider about the momentum, it is very important to consider its direction. So you need to keep in mind. I will show you that what is the meaning of this momentum mean. Yeah, you can see the how much even you can move the body. If it is collide with another body, then how much it will be damaged to the system means it's the larger momentum. That's larger the momentum, the damage is also large. Smaller the momentum, the damage is the momentum can be increased by increasing the mass and also by increasing the velocity. That's why you consider this, right? Here, let's say you have the mass that's a 1000 kilogram mass, but it's moving with 0.1 meters per second speed. So momentum of this body will be that 1000 into 0.1 is 100 Newton second. You have another mass, it's a smaller one. So it has a 10 gram of mass, right? But it's moving with 1000 meters per second. Here I'm considering this as it's moving with 0.01 meters per second. Okay, then the momentum is 10 newtons second. Clear? And here this 10 gram of mass is moving with 1000 meters per second. That's the momentum is then that is 10 into 10 to the minus 3 kilogram into 1000. So it's also 10 newton. You can see that's a very smaller mass, even though it's moving with a much fast or the higher speed, it can make the same damage as if given the damage by the 1000 kilogram mass moving with 0.1 meters per second. Then අපි දැන් උතන පොඩි චූටි bullet එකක් fast moving ඒතකොට the single bullet is enough to dead the body. يعني කෙනෙම ඒකෙන් මේ බෙල් එකට තිබ්බොත් බෙල් එක ඇල්ලක් ගලවලා යන ගානට විතර ලොකු ඉෆෙක්ට් එකක් දෙන්න පුළුවන්. හරි. ඒ වගේම ඉෆෙක්ට් එකක් වෙනකොට මේ වගේ bigger mass එකක් very small speed එකකින් ආව දැන් ගල් රෝලක් වගේ එකක් ආවොත් එහෙනම් හිමින් ඒකට යට වුණොත් එහෙම ඒ අර දෙම වගේ තමයි වෙන්නේ. හරි. කියන්නේ momentum එක එතකොට හැමතිස්සෙම always not only depend on the velocity, it depends on its mass also. දැන් අර බෝම්බයක් ගහනකොට ගොඩක් වෙලාවට තනිකර එක කුට්ටියක් විදිහට හදන්නේ නැහැ. බෝම්බයක් හදන්නේ සාමාන්‍යයෙන් ඒක ඇතුලේ පොඩි පොඩි masses ගොඩක් ඔය bicycle ball වගේ ඒවා ගොඩක් තියෙන විදිහට. ඒතර ඉතින් blast වෙනකොට මේ all the small pieces are moving much faster. ඒකට ඒ එක එක කෑල්ල ගිහිල්ලා ගොඩක් පටේටම විසිරීලා යනකොට ගොඩක් අයක වෙලා ලොකු ඩැමේජ් එකක් ගන්න පුළුවන්. වෙන්න තමයි මම හදන්නේ. මොකද එක කෑල්ලක් විතර මෙහෙම ගියොත් එක ගිහිල්ලා කාය එක්කෙනෙක් වැදුනා එතනින් ඉවරයි ඊට පස්සේ. සිස්ටම් එකේ දෙන ඩැමේජ් එක අඩු වෙනවා. ඒක වැඩි කරන්න නම් ඔයගස් අපි කියන මොමන්ටම් කන්සර්වේෂන් එකත් කතා කරමු. හරි. Okay, then very important to get the change in momentum, right? මේක මම කරනවා. ඔයාලට ඕන මේ examples දෙන්න යන්න හරිද? The change in momentum is important here. We always like to take the momentum change of momentum. So this is the difference between that final and initial momentum. You can say in the change of momentum is that final momentum minus initial. When you consider this change, it is very important to consider the direction. That's why this part is important here, right? In most of the cases, the students fail to get the change in momentum because in some cases, when the ball, let's say the ball hits on the wall and then rebound, then you can see that initially momentum is into one direction and the final momentum is opposite to the initial direction. So then you can't subtract these two as mathematically, so numerically subtract and bad. You have to get the vector subtract, vector addition methods to get the difference of two momenta. Here, let's see, I'm considering here that's one case when the body, let's say, the moving to one direction is a velocity u and mass m, and this velocity under the force acted on it, it say its velocity increases to v. Right. So this initial momentum is mu, at mu in this direction. Final momentum is mv, that is the same direction. So in this case, you can take the change in momentum because of both the same direction as mv minus mv. Clear? So this is the change in momentum of this body. This don't matter. Another case I'm considering, this is first case. Second case I'm considering that. Let's say there's a wall. And the body is moving with the velocity u, this wall, and this is the before collision. Then after the collision, the ball is rebound with a different velocity, opposite direction. That's rebounding, right? So in this case, that is after the collision, the ball. So in this case, the initial momentum is mu, rightward. The final momentum, that's mv, leftward. To get the change in momentum, delta p, you need to get the pf minus pi. These are vectors. The pf is the mv, leftward, minus the mu, the rightward. These two momenta and your different opposite directions, you cannot directly subtract them. You need to change the direction. By changing the direction of a vector means you need to multiply it by the negative sign. So then the minus minus become plus, and the change in momentum becomes m times v plus u. So in this direction, this is the direction and the magnitude of the change in momentum when the ball hits on the wall and rebound. It's clear? That's the way you need to get the momentum change of the body there. Clear? Where is this one? This is mentioned in your tutorials. That's another thing the another case I will consider. That's not in your handout. If you can note it down, right? මම මේක තව එකක් කියන එක ඕකේ නෑ මම ඒක note it down කරගන්න හරි මම මේක මතනවා ඒ අපි බලමු මේක නිකන් angular මේ වගේ collide වුණොත් wall එකක් එක්ක it's moving towards the wall with some angle. Let's see this is with the angle alpha. It's moving towards, this is before collision, right? Before. After, it's moving another direction, right? After collision. So you come with the velocity u and mass m, the same mass moving in the velocity v. This makes an angle alpha, this makes an angle beta, let's say. So how you get the change in momentum? In here, you can consider the momenta. There are two different directions, opposite, two perpendicular directions actually, right? Two perpendicular directions you need to be considered. And initially, this initial momentum in x direction of this body, that is make u cos alpha. So then the momentum will be u mu cos alpha in this direction. And initial momentum in y direction, so you can see it's in downward. So it is minus m u sin alpha. Down the plus downward. Clear? Make it in components. You need to consider the components. This mu cos alpha, mu sin alpha. And here also the two components are there. The final momentum in x direction, it is mv cos beta in this direction.